how can you determine whether a salt will be acidic or basic and neutral? So some of the questions you might see say, let's put some salt in the water, what's going to happen to the pH? What are you going to be looking for? If it's going to be an acidic solution, you're going to have a positive ion, which is not an alkali metal, because positive ions, what they do is influence water to actually make it more acidic. They make the water more acidic by having a positive ion. Again, only if it's not an alkali metal. The reason for that is because alkali metals have a small positive charge. If you start having alkaline metals, or if you start having iron or aluminum, something with a bigger charge, like a +2, +3, now that's going to be more influential on the water. But all you need to know is that if you have a positive ion, which is not an alkali metal, you put it into water, that's going to make the solution more acidic. For example, if you put the salt aluminum chloride, this salt, when you put it into water, is going to separate into aluminum ions and chlorine ions, or chloride. This aluminum ion, having this big positive charge, can cause the solution to become more acidic. How do you know something to be a base if you put it into water? If you have a negative ion, which is not the conjugate base of a strong acid. Again, conjugate bases of strong acids are so weak that we call them neutral. Meaning like this guy right here, this is the conjugate base of hydrochloric acid. This guy's neutral, he doesn't react. So, this negative ion would not do something. But our example over here, we have sodium carbonate. We have Na and CO3. This Na, he's an alkali metal. Because this Na is an alkali metal right here, he's not going to cause the solution to be acidic. But we see this other negative ion here, this anion, carbonate. We don't recognize him. We don't recognize him as one of our conjugate bases of our strong acids. Because we don't recognize him, this CO3 here is a negative ion who is not a conjugate base of strong acid. He makes the solution basic. Again, this one's a little easier to understand why. If you're negative, you can attract a hydrogen to yourself. So if you put carbonate into water, this -2 charge is going to start pulling hydrogens off of the water, which is going to cause that water to turn into hydroxide, making the solution more basic. Your salt will be neutral if you have an alkali metal and a conjugate base of a strong acid. For example, if we had a salt KCl, this salt here, that's going to be neutral. Why? K is an alkali metal, Cl is a conjugate base of strong acid. This salt right here put in water is going to be neutral.